In earlier videos, we discussed about the refraction through lens whenever the light is incident on the lens, or convex or concave, means converging or diverging. Then here that is the one of the part, and now we are going to discuss about the when the light is incident on the prism, then means refraction will be happened, means actually refraction through a prism. When the light ray is passing from the prism, then here what is meant by the prism? First of all, we should learn what is prism. Prism means it's a wedge shaped body, with made up of with a transparent refracting medium, transparent refracting medium, bounded by two plane surfaces inclined to each other. Means here two surfaces is called refracting surfaces. Means here this one is the refracting surface, and another one is this one is a refracting surface. Here two surfaces are refracting surfaces are with some angle that is denote angle of prism is called A. That is denoted with A. Means it's a wedge shaped body of made up of with a transparent material medium, refracting medium of two surfaces, means which is both are inclined, and the angle between the two surfaces are is angle of, that is called as angle of prism, that is A. This is are inclined to each other. Then the angle of prism, when the line means here the line which the refracting faces of the prism meet, which the refracting prism the meet, this is the refracting prism meet, faces of the prism meet is called edge of the prism, where the refracting surfaces is this one, and this is called as here the line along which the refracting faces of the prism meet. This is one of the refractive face, and this is another refractive face, both meet at this line, then this line is called as edge of the prism. This means to say edge of the prism. This is about prism. Next, when the light is passing through the prism, then it will get refracted from the two surface. Means when the light is incident on this surface, then it will refracts, and it will incident on the second surface medium and another refraction. Then we are going to know that what is the deviation happened when the light is incident on the prism. So the deviation produced by prism means here if we take the prism which is having the two inclined surfaces. This is the one of the surface, and this is one of the surface, and this is the base, that is A, B, C prism we have taken, and this is one of the normal for the one refractive surface, and this is another normal for another refractive surfaces of the prism. And when the light incident on one refractive surface with of incident angle of I, this is the angle of incidence I, that is from the P ray is incident at a point of Q, we are taking that, we are considering it's a point Q, and it is refracted through a prism which is parallel to the base at point, and it is emerged into from the second refractive surface, it is emerged along the direction of RS with emerged angle E. Means when the light is passing from the one refractive surfaces to the another refractive surfaces, this incident ray and emerged ray will not be parallel because of the two surfaces are inclined and together, both are inclined. So this incident ray PQ and the emerged ray RS is not equal. So here it is that we can write that here is PQ is a incident ray, PQ or incident ray, and RS be the emerged ray, we can say that refracted ray, and this is the angle of incidence I, and whenever the normal taken, two normals are enlarged, and this will be the point we are taking that N, and these are the at angle Q and at angle R are the right angles, at the right angles. So here is that if in case of if we don't consider the second one, I mean so there is no any prism, if there is no prism, light must move in the direction, in this direction, light must move in this direction. But due to the when we place it in front of the light, then the total light is deviated. This is deviated. This is the angle of deviation delta. Angle of deviation delta at a point of m. Considering at point of m means here the angle of refraction will be, this is the normal, and it is whenever it is moving from the rarer medium to the denser medium, the light ray bends towards the normal. So that's why that angle of deviated in this direction, that is angle of R1, and if in case of here is that R2, then that angle Q and R are both are right angles to the quadrilateral AQNR. In this right QNR, from quadrilateral AQNR, here the Q and R both are right angles. In quadrilateral AQNR, the two angles, angle Q, angle R are right angles, So right angle. So that's why we are writing that angle A plus angle angle A plus angle N. Here is that N. Angle A plus angle N is equal to 180 degrees. Angle A plus angle N is equal to 180 degrees. From that equation, we can write that angle N is equal to 180 minus A. 180 minus A. It is equal to equation number 1, considering it's a given number, that equation number 1. Once again, from the quadrilateral AQNR, then the Q and N are right angles, means this is the right angle and this is one of the right angle at R and Q. So here it is that then the angle A plus angle N is equal to 180 degrees. So from that angle N is equal to 180 minus A, that is equation number, considering equation number 1. Next, from triangle QNR, from triangle QNR we can write that QNR. Here that the angle at Q is in QNR triangle, angle at Q is R1 and at R is equal to R2 and N be the angle N, means from QNR angle N plus angle Q plus angle R is equal to 180 degrees. Angle N plus angle Q plus angle R is equal to 180 degrees. But we know that angle Q is R1, means here is that angle QR, means here we can write that a QNR triangle, here that is angle N plus R1 plus R2 is equal to 180 degrees, means angle N is equal to, we know that from the equation number 1, that is 180 minus A. So we are writing that 180 minus A plus R1 plus R2 is equal to 180. 180 get cancelled. Whenever the minus A taken to this side, then R1 plus R2 is equal to A. Consider equation number 2. Considering equation number 2. Then the angle as a deviated, means when if there is no prism, light has to move, light will move in the straight line. But due to the prism, the light refracted, whenever the light is moving from the prism, inside the prism, that will be parallel to the base. That refracted light is parallel to the base, and here from that equation we got that here the deviation has possible, means here whenever the second surface, these two are not parallel, already we know that, means the incident ray and emergent ray are not parallel. The angle between the incident ray PQ and the emerged ray RS is called angle of deviation. Means this is the incident ray PQ and this is the emerged ray RS. Then the angle between both is called as angle of deviation. Means angle of deviation. Angle of deviation is the angle between incident ray and emerged ray is called angle of deviation. Angle of deviation delta, that is denoted with delta. All we know that. So here is that from that deviation we can write that the angle of minimum deviation is possible. Means here the deviation, actually the light has moved in this side, but in case of this side, so that's why this angle will be, this is I, the angle we should know that I minus R1 be the equation angle, and here is that angle is E minus R2. So here is that the angle of deviation delta is equal to the sum of the two angles at Q and R. So here is that the delta is equal to angle of deviation delta is equal to at point M, delta is equal to I minus R1 plus E minus R2. From that relation we can write that delta is equal to I plus E minus of R1 plus R2. R1 minus, when we get the common for minus, then we can get that if we multiplied inside the R minus R1 minus into plus minus R2. From that relation we can get the same equation. Then from the relation again we can write that we know that from equation number 2, from equation delta is equal to I plus E minus A. Consider this is equation number 3. Consider that is equation number 3. We can write that the angle of incidence, the sum of the angle of incidence plus angle of emergent ray, which is equal to the angle of deviation, the sum of the angle of deviation and the angle of prism. Means here is that we can write that delta plus A is equal to I plus E. Means here is that we can write the equation, means we can write that delta means angle of deviation, A means angle of prism, and here I means angle of incident and E be the angle of emerging. Means here the angle of incidence, angle of emerged ray, the sum of the angle of incidence and angle of emerged ray is equal to the sum of the angle of deviation and angle of prism. We can define by using this equation. So from the above equation, means equation number 3, we can modify whenever we take that minus A into in this side, then a delta plus A is equal to I plus A. That means to say the angle of deviation, the sum of the angle of deviation and angle of prism, which is equal to the angle of incidence, sum of the angle of incidence and emerged ray. From that, if according to the from the above equation, when the angle of incidence increases, then also the angle of deviation is also increases. Means slightly whenever it increases, passing through a prism, passing through the minimum deviation, and at a certain point again it will increases. Means when the light is passing through a prism, for a certain value of deviation, so certain value of deviation, the angle of incidence, they both emerged ray and incident angle will be the equal for a small deviation at this point. Means whenever the angle of incidence is increases at IN is equal to I, then from that angle of incidence the deviation will be increases, goes on decreasing, and again it will comes to at some point light suffers when through a prism, light passing through a prism, it suffers a minimum deviation for a certain value. That certain value is called as a minimum deviation. Minimum deviation means light suffers minimum deviation for certain angle. At that there is minimum deviation, when we can get that I1 is equal to I2. That means to say I2 means here is the emerged angle. I2 means the emerged angle will be same at the sum of the points. This one is I1 is equal to I2 means the angle of incidence which is equal to emerged ray for a minimum angle of deviation. At a certain point the values will be same. So from that rays we can write that the minimum deviation, the deviation delta is equal to delta m, then I1 is equal to I2, that is equal to I2 means here we can write that E, that is I1 is equal to I2, and also we can write that R1 is equal to R2 is equal to R. That means to say here the angle of refraction R1 and R2 will be equal to, both are will be same, because of at an angle of deviation will be same, then the angle of deviation, the R1 and R2 angles will be the same. So here the R1 is equal to R2 is equal to R. If we substitute these equations, the values in the equation number 2 and 3, then we can get, if in case of equation 2, then in equation 2, then what we can get? Let's see. Delta is equal to R1 is equal to R2 is equal to R, means here we can write that from 2 equation 2, R plus R is equal to A, means 2R is equal to A, or angle of refraction R is equal to A by 2. Next, consider it's a equation number 4. Next, if in case of the angle of incidence, we can write that from the deviation delta is equal to I plus E minus A. I plus E minus A means here delta is equal to I plus E, means we know that both are will be same, means I1 is equal to I2 is equal to I. Then we can get that from equation number 3. From equation 3 we can write that here that delta M plus A is equal to 2I, angle of incidence I, then I is equal to A plus delta M by 2, means this is the angle of incidence for minimum deviation. The minimum deviation, consider it's equation number 5. From these two equations are given, equations are from the Snell's law. We have that from Snell's law we have that mu is equal to sin I by sin R. Here refractive index of the prism means, that means to say 2,1 means mu 2,1 means the mu is the mu 1 is the whenever the light is incident from the air, whenever the prism is placed in the some of the medium, that medium refractive index is mu 1, and mu 2 be the here mu 2,1 is equal to mu 2 by mu 1. That from that case we can write that we know that I value and R value, so that why mu is equal to refractive index of the prism. Here mu is the refractive index of the prism. Refractive index of prism mu is equal to I is equal to A plus dm by 2, means sin of A plus delta m by 2 by here R is equal to A by 2 from equation number 4, sin A by 2. Here is the equation for refractive index of the prism, that is sin of A plus dm by 2 by sin A by 2 be the equation for minimum refractive index of the prism, expression for the refractive index of the prism. So once again here the deviation produced by a prism means PQ be the incident ray. When the incident ray is incident on the refractive surface of the one refractive surface of the prism, then the light will refracted to this parallel to the base and incident and emerged from the second refracting surface and moved into the direction of RS then from the relation from the quadrilateral AQNR, the Q and N are right angles, so that's why we are taking that angle A, angle N is equal to 180 degrees. From that angle N is equal to 180 minus angle A taken this side. Then from that in the triangle, from the triangle QNR, from the triangle QNR, the refracted angles is there. So angle N plus R1 plus R2, angle N plus R1 plus R2 is equal to 180 degrees. From that, but we know that angle N is equal to 180 minus A, from the relation R1 plus R2 and is equal to 180 get cancelled, then R1 plus R2 is equal to A. That is the equation number 2. So here the angle means whenever there is no prism, light moves along a straight line, so that's why, but in case of the prism the light has deviated and emerged ray in the direction of moved in the emerged ray direction, so that's why the angle between the incident ray and emerged ray means this is the incident ray, this is the emerged ray, so that's why it is the angle of deviation between the angle between the incident ray and here emerged ray is called as angle of deviation. So from that angle of deviation, the delta is equal to angle of two others, so the I by I minus R1 plus E minus R2 be the angles. So delta is equal to I minus R1 plus E minus R2. By the calculation we got that delta is equal to I plus E, delta is equal to I plus E minus R1 plus R2. From that relation also we can get that from the relation second two relation from the equation number 2. So R1 plus R2 is equal to A, then delta is equal to I plus E minus A, I plus E minus A means a minimum deviation delta, angle of deviation delta is equal to incident angle plus emergent angle. That means the sum of the deviation plus angle of prism, sum of the angle of deviation, angle of prism, which is equal to the sum of the incident angle and emerged angle, that is delta plus A is equal to I plus E. From the above equation, when the light, if we plot a graph between the angle of deviation to the angle of incidence, then we can get that initially when the angle of incidence increases, initially the angle of deviation is also increases and goes on decreasing, it suffers with a minimum deviation, passing through the minimum deviation. At certain points the angle of incidence and angle of emerging both will be the same for sum of the angle, and whenever light passing through a prism, light suffers the minimum deviation, that at that angle, the angle of minimum deviation, that angle where the light suffers minimum deviation is called as angle suffers, that at that angle the angle of incidence is equal to angle of emerging rays also, both will be same. So that's why I1 is equal to I2, that is equal to E also we can write that, because of I2 angle of incidence second one is E. So from that I1 is equal to I2 is equal to I, and angle of deviation will be equal to minimum deviation at that point. So that's why angle of deviation is equal to minimum deviation, then angle of incidence and angle of emergence is equal to, both will be same. So that's why at a position certain value, so that is I, and refraction is also same. So that's why R1 is equal to R2 is equal to R. From that relations we can write that R1 plus R2 is equal to A. From the relation R plus R is equal to A, 2R by A, 2R is equal to A, then R is equal to A by 2. From the third relation, delta M plus A is equal to 2I. From we have the relation fourth, the third relation. In this relation, if we substitute that, I plus E is equal to, both are the same. So I plus E is equal to I. So I plus I, 2I, 2I minus A. 2I minus A means minus A taken this side, then delta M plus A. I is equal to A plus delta M by 2. This is the incidence angle. From the, if we substitute these values in the Snell's law equation is there, the refractive index of the prism mu 21 means mu 2 by mu 1 is equal to sin I by R, angle of incidence, sin of the angle of incidence by sin of the angle of refraction. So that's why from the relation, if we substitute those 4 and 5, from 4 and 5, if we substitute two equations, then we can get that the refractive index of the prism mu is equal to, the refractive index of the prism mu is equal to sin of A plus dm by 2 by sin A by 2. dm by 2 means here that delta m be the minimum deviation. We can write d instead of delta m, we can write dm also. We can write dm also. Instead of delta m, we can write dm also, delta m also. Both are will be the same here. Dm means here minimum deviation. Minimum deviation. Minimum deviation means where the lights are passing through a prism, it suffers minimum deviation at the angle of incidence and emerged ray will be equal, and the angle of refractions is also same. At that angle, that angle of deviation is called as a minimum. So this is about a refractive index of a prism.